let us discuss particle physics. So we will classify particles today. So we will divide particles in broadly two categories. First of all, leptons and hadrons. Clear? Now we will discuss leptons. There are total 12 leptons. So we will divide it to broadly three categories, and first is electron, then neutrino, then muon, then muon neutrino, and last we have tau and tau neutrino. So we will have three elements, three particles, electron, muon and tau, and for that we will have, each will have a neutrino. Electron neutrino, that we will say as neutrino only, and for muon we will have muon neutrino, and for tau we will have tau neutrino. Now these are six particles. For each of them we will have antiparticle, that is let me write antiparticles. Okay, so we will have, for electron antiparticle is this, and for neutrino antiparticle is this. For muon antiparticle is this, and for muon neutrino antiparticle will be this. We will denote it by bar. And for tau we have antiparticle this, and here we will write this symbol. So minus and plus, all we have minus, then we will change it to plus. Then for antiparticle we have this. Great. Now what you say this three category? This is first generation, this one second generation, and this third generation. So total 6 particles, that are electron neutrino, that is neutrino, muon neutrino, tau neutrino, and for this we will have an antiparticle, that we will write as antiparticle. For this we will have, all will have antiparticles, and total we have 12 leptons. So leptons can be classified into 12 different particles, that is electron neutrino, muon neutrino, tau neutrino, and each one will have an antiparticle, as in this is called positron, this one antiparticle of neutrino, antineutrino maybe, then muon, and each one will have a antiparticle. Clear? Now we will discuss second part, that is hadrons, and we will classify this into two parts. This is mesons and this one we will say baryons. Now first we will study mesons. Mesons will be divided in three particle groups. First pions, then kaons, then eta particle. Okay, now we will write their symbol. This will have 3, pi plus, pi minus, and pi 0. Kaons, we have 2, k plus, k 0, and eta a single particle. So this is also named as there are 3 particles, this will be said as triplet, this one as doublet, and this one singlet. For each one of this we will have this all are said to be meson particles, that is pions, kaons, and eta. Now let us study baryons, and baryons will be divided further into 2 categories. First one nucleons and second one hadrons. So nucleons will be, let it be black only, nucleons will have neutron and proton. So neutron we will denote it by the symbol neutron and proton by P. This is doublet, and these are considerably singlet and singlet. Now we will discuss hadrons. For now, you just remember hadrons, we also call them as strange particles. What are strange particles, its characteristics we will discuss later. So for now we will say strange particles as hadrons, and hadrons can be divided in 4 subparticles, that will be sigmas, cascade, lambda, and omega. So now we will write their symbol. Sigma we will write it as sigma plus, sigma minus, and sigma 0. Cascade as, these are called cascade brackets, this minus and 0. And lambda 0 omega, omega minus. So this we can see it is triplet, this is doublet, and these both are singlets, singlet, and this one also singlet. Great. So we have hadrons divided basically in two parts, that is mesons and baryons, and mesons further divided in pions, kaons and eta, baryons further divided into nucleons and hyprons, whereas nucleons further divided into neutron and proton, and hyprons further divided into sigmas, cascades, lambda and omega. This is the chart we must remember for proper knowledge of the particles. Now let us discuss quark. First, in the first video we have discussed what is quark and what is its existence for. These are fractionally charged particles. Now we will discuss the various types of quarks. We have in total 6 quarks, and each with its antiparticle, means anti-quark. Anti-quark. So what are they? Up, down, top, bottom, charm and strange. Now these three will have charge, as we said, fractionally charged particles. So this will have a charge of 2/3, and this down, bottom and strange will have a charge of -1/3, and the total 6 quarks will have baryon number is equal to 1/3. And what we will denote all these quarks with? Up with U, down with D, top with the initial letters T, bottom with B, charm with C, and strange with S. So all this will have anti-quark. These are quark and anti-quark we will denote by U bar, D bar, T bar, B bar, C bar and S bar. So anti-quarks are denoted by this, and this quark value, as I said, baryon number will be 1/3, and for anti-quark the baryon number will be -1/3. Now you must be wondering whether quark can exist as single quark can exist or not. If I say single quark exists, then we must say that quark, that particle, if denoted by single quark, then it will have a fractional charge. But we were told from beginning that fractional charge does not exist. So how is that possible? So we can conclude from here that quark cannot exist independently. A single quark is not possible. There we will have 2 quark or 3 quark or so on. So now we will discuss another important property about quark. As I said previously that particles are made up of quark. Made up of quarks. So quarks are the fundamental particles. Now which we will get to know later, that proton is made up of quark, that is up, up, down. So here we have two up quarks. But it violates Pauli's exclusion principle. So to not violate the Pauli's exclusion principle, we will introduce color charge of quarks. Now, listening to the word color, what will cross in our mind? That the physical meaning of color which we use in our day-to-day life, but we must be very clear that it is unrelated to everyday meaning of color. Meaning of color. So now what choice of colors do our scientists propose that time? We have red, blue and green. So let me give this by red, this one as blue and this to be as green. So red, blue and green. Now when all three colors mixed together, or any one of these colors and its complementary color, and its complementary is colorless or white. So this was the basic idea of proposal of color charge of quarks. So if I say, for example, we have U, U, U and U. So will it exist? If I say so, the answer will be no. But why? Say I have this up quark as red, this one as blue and this one as green. So the remaining one quark can have the color red, blue or green without its anti-color, means without its complementary color. So this will violate our Pauli's exclusion principle. So it will not exist. Now let us say, for example, we have some particle as this. So will it exist? Yes, it will. And we can give one more example for that, as say Q, Q and Q as a bunch of color, and we have Q and a Q bar. So will it exist? Yes, it will, because we can reduce it as red, blue and green. this one will be colorless or white, and it will cancel each out. And this, if we take as blue, red, then it will be its complementary color, red bar. For blue also it's complementary, and for green also it's complementary. So let me write it as red and its complementary color. So this one will also exist. So that's all for today. Thank you. Next day we shall discuss baryon, octet, mesons, and we will discuss isospin and other things as well. So that's all for today. Thank you.